Hello, everyone. I'm Wes Purvis, and we're going to talk about wireless. Can't start without talking about Wi-Fi 6E, 6 gigahertz, Wi-Fi 7. I wanted to put up a scorecard of kind of where, what we see from our customers, where we are. And so we are 2.5, 3 years into Wi-Fi 6E. And of all of the Wi-Fi 6E capable access points that we have shipped, 50% of those APs have 6 gigahertz enabled. JD.
Are those users who think they have 6 gigahertz enabled but haven't enabled a WPA3 SSID?
No, this is...
Those are radios that are shut off.
The radios that, I looked at it the other way, how many radios are enabled. So these are 6 gigahertz radios that are enabled beaconing, which means they have WPA3 configured.
Okay, awesome, thank you.
So there's a lot of room for improvement here, although this is, even a year ago, that number was 30%. And so there's been a significant uptick. From a client adoption standpoint, we're in the 20 to 50% 6 gigahertz adoption, depending on the environment. So if it's a BYOD environment like a university, that number is usually trends lower. If it's a corporate environment and that with corporate issued devices, and that company has begun refreshing with 6 gigahertz, which many of them have starting several years ago, we're seeing upwards of 50% or even higher in some environments of 6 gig clients. From a Wi-Fi 7 perspective, we're seeing client adoption in the 5 to 10% range right now, which is in first year of rollouts, kind of what we would expect. That's what we saw with 6 gig. So here's an example customer where they deployed. They have about 1,600 clients on the network. About 34%, so 530 at this point, are connected on 6 gig. And then 142 of those clients are Wi-Fi 7. So just to, this is where we are in the journey. The 6 gig adoption is really picking up, and then Wi-Fi 7 will take several years to reach a critical mass. That leads into, all right, how about channel width, right? Because channel width has a direct impact on the speeds that a user is able to achieve on the network. So if we look at 5 gigahertz, our default channel width, if you go deploy a Mist network, our default channel width on 5 gig is 40 megahertz. But the majority of our customers are using 20 megahertz on 5 gig, which is great. Everybody, or many people, are changing the defaults, which is always good to see. On 6 gigahertz, the story is a little different. Worldwide, we see generally 80 megahertz channel width. That's our default. In Europe, the majority channel width is 40 megahertz because there's not as much spectrum. I think over time, as 6 gig adoption increases, these channel widths will shift left. So, I think once we get appreciable adoption, you'll kind of, at least in the US with 1200 megahertz, if you do 20 megahertz on 5 gig, you'll likely be able to do 40 megahertz on 6 gig in most circumstances. And then in Europe, probably that means going down to 20 megahertz in dense environments on 6 gig, which some of our customers have already started doing. So then that brings up the question of how do clients actually handle 6 gigahertz? Like, do they use it? Do they connect? And so what we see is actually a very strong affinity from clients to 6 gigahertz. They generally prefer 6 gigahertz. Most of them are programmed to prefer wider channels, but even when 5 gigahertz and 6 gigahertz have the same channel bandwidth, we actually see very strong affinity. So here is a client that is roaming. This particular client happened to roam 350 times, over 350 times on this day, and every single roam was 6 to 6. Now that's not always the case. You will see some interband, but generally speaking, affinity is pretty good. And as an example, here is a network that had somewhere in the neighborhood of 26 or 27,000 clients in the past 2 weeks. So about 16,000, a little over, 5 gig only, right? We only ever saw them connect on 5 gigahertz. Another 7,000 connected on 5 and 6 gigahertz at some point in that 2 weeks. So those are 6 gig capable clients. But the most interesting stat here, to me at least, is over 3,000 clients connected on 6 gig only. So in that 2-week period, we only saw those clients on 6 gig. They never connected on 5 gig.
Did you see a preference for device type, whether that's Android or Google specifically, Samsung, iPhone? Did you see a preference for one that kind of preferred 6 only?
Yeah. So the Apple devices, from what I see, have the strongest affinity to 6 gig. They, you'll seldom see them on 5 gig in a like dual band SSID. Then Android is kind of next level down, and then Windows is usually kind of third. Sort of. That's how I see.
Do you have any stats on MLO?
Not that I'm not in here. Yeah.
Right. I'm just, as you're talking about, I wonder about clients that are connected on 6 and 5, 6 and 2.4, right?
Right.
How are you going to manifest? How are you going to show roaming and?
Right. Yeah. I don't have anything on MLO specific. Okay. But yes, you have to show it all, right? And we will.
Okay.
Okay. So then, but kind of related, the precursor to being able to do MLO is security. And so Wi-Fi 7, just like Wi-Fi 6E, introduces some mandatory security features. So Wi-Fi 6E, you had to do WPA3, right? On 6 gigahertz, you have to do WPA3. On a Wi-Fi 7 SSID that can be on any band, there are a couple things that you have to do as well. So one of those is GCMP 256 cipher. So you have to use GCMP 256. Generally, we're using CCMP 128 for most things today. You have to turn on beacon protection, and you have on a WPA3 personal, you have to turn on this SAE GDH or extended caps. You'll also see it called. And the way this is manifesting and what what Wi-Fi Alliance is recommending is, generally speaking. So this is a beacon RSN element. In the beacon, I think most people are familiar with with the AKMs, the key management. This is how the AP, the BSSID advertises, hey, this is my security. This is what I can do. I'm OWE, I'm enterprise, I'm personal. But in the pairwise cipher list, typically that's always been CCM and at least for WPA3. But for Wi-Fi 7, generally the recommendation is to add GCMP 256. So you will usually see both advertised on Wi-Fi 7 networks. It looks the same, whether it's WPA3 personal, enterprise, OWE. You'll see multiple AKMs, but now you'll also see multiple ciphers as well. So again, every single Wi-Fi 7 BSS has to advertise GCMP 256, has to advertise beacon protection, and then if it's SAE, has to advertise SAE GDH. So what does that mean for roaming? Now, if you have a complete Wi-Fi 7 network where you're going from Wi-Fi 7 AP to Wi-Fi 7 AP, security is the same on both sides. AKMs are the same on both sides. GCMP is there, beacon protection is there. Very good roaming. So as you'd expect, roaming is smooth. Now, I don't necessarily think that this will be every customer deployment, right? Because many deployments will have mixed APs, right? We don't yet sell a Wi-Fi 7 outdoor AP. In the real world, we will have mixed, Wi-Fi 6, 6E, Wi-Fi 7 environments. That's just the way it's going to be. So how does that look like? Well, let's say you don't make any changes, right? You take your configuration as it is today with your Wi-Fi 6 or 6E APs, and then you just add Wi-Fi 7 APs with Wi-Fi 7 enabled. It all works well with older clients, but the newer clients that are capable of GCMP 256, which there are actually quite a few of them out there now, because if the client supports WPA3 192-bit, they likely already support GCMP 256. And so the problem is, let's say I'm connected to a Wi-Fi 6 AP. I'm connected at CCMP 128, right? I roam to the Wi-Fi 7 AP, and as the client, I say, oh, this can do GCMP 256. That's better. That's more secure than CCMP 128. I'm going to change to that. But the problem is, it's not seamless. You will have a disruption there. And so what that means is really for seamless roaming, you have to actually enable GCMP 256 on your Wi-Fi 6, 6E APs for the most seamless experience. And this doesn't matter the security type because you have to turn on GCMP 256 for every security type. Now, this isn't all that different from what we went through with Wi-Fi 6E. Right? You had to turn on WPA3. You're probably not mixing just WPA2 and on your older stuff, WPA3 on newer stuff. It's generally one shot. So I don't think this is going to really be a big pill to swallow, but just it's a consideration to know about that. You'll have to turn on at least GCMP 256 on your older stuff. Beacon protection doesn't really seem to matter on the older stuff. It doesn't affect the roaming. It's really just the GCMP 256 for the clients that are capable of supporting it.
Feels a lot like something I want Marvis to tell me and go fix.
Yeah, or the cloud will just configure it.
Yeah, it's automatic.
Mist, this won't really be a concern. I just want to point out that under the covers, this is something that will happen. And we've actually, we've had since Wi-Fi 6E with WPA3, there's been a lot of discussions around client interoperability. And we haven't seen interop issues. Granted, we don't have massive exposure to GCMP 256, but of the clients that we've tested, the environments that we've been in, turning on GCMP 256 seems to be a non-issue.
Do you only turn it on the 6 gigahertz band?
Nope.
You do it as well if you're broadcasting?
You have to do it because Wi-Fi 7. You can turn on Wi-Fi 7 on any band.
Yeah, you're right. Yeah.
So any SSID that broadcasts Wi-Fi 7 that supports Wi-Fi 7 has to have GCMP 256. Doesn't matter the band.
Okay.
But you are saying that the clients that you've tested do support the GCMP 256?
Yeah, kind of the newer clients. Yeah, absolutely.
Newer clients.
How
new?
Basically, any client that supports WPA3 192-bit, which has been out, for 4 years. In the mainstream.
Are these going to be the default values if I spin up a new SSID?
Yes.
It's best interoperability?
Correct.
And when will these be the new values, even if I don't have Wi-Fi 7 APs on my network?
We will tie it to a value, like there will be a Wi-Fi 7 configuration option on the SSID.
Okay.
If Wi-Fi 7 is enabled, we will enable all this other stuff.
Okay.
Now, is there a standard naming convention you're going to use, or has that been defined by a group?
Like how it's going to look like in RUI?
Yeah.
Wi-Fi 7 enabled. It's just like it's already there actually.
Okay.
Just like we had the Wi-Fi 6 enabled disabled box, there's a Wi-Fi 7 enabled disable per WLAN. All right, that's roaming. So how do you actually migrate to Wi-Fi 6E, Wi-Fi 7? So as I mentioned, only 50% of our APs, 6 gig APs, have 6 gigahertz turned on. So there's still a tremendous opportunity. And when I talk to customers, there's still apprehension out there. I think mostly about WPA3. There's some power, apprehension as well, but mostly it's WPA3. So, this is my, high-level blueprint of, how can you actually get to 6 gigahertz, and now, how can you also actually get to Wi-Fi 7? Well, first and foremost, try WPA3. You don't have to have 6 gig capable APs. You don't have to have Wi-Fi 7 APs even to get your feet wet with WPA3. And it's something that you should be doing today because you will have to go to WPA3 at some point. Now, you don't have to do it on every SSID, and you can be strategic with it. A lot of times what folks will do is on their .1x SSID, they will turn on WPA3 for, because that's been the lowest risk. Now, we're several years into this, right? And there's been a lot of discussion on interop, especially with WPA3 personal. Largely not a concern anymore. In most of our networks, 99.9% of clients are, supporting WPA3 personal. They're still in the back of your mind, hey, am I going to have an interop issue? But, people that I've turned on, just move on, right? If you might, if you have a couple clients, okay, go deal with those. And same for OWE. We've had many customers now who have turned on OWE or OWE transition for guest networks in particular, and it's been pretty smooth, to the point where it's still on. Right?
What's your take on the IoT impact for WPA3 adoption?
I think so. For IoT devices, I think in many cases you're not turning on Wi-Fi 7 on that SSID, and the ones that you are, it's still like, hey, do they support WPA3? If they're not supporting WPA3, it doesn't matter if it's Wi-Fi 7 or not. They're gonna struggle.
So you're thinking for the foreseeable future, then it's still advocating separate SSIDs for IoT, largely because of WPA3 or lack thereof support.
Yeah, and it really comes down to device by device. Like, there are many older devices that certainly don't support WPA3, but I think we've even seen some, recent devices, IoT devices that aren't supporting WPA3. And so it comes down to what's in your environment, test it out, see if it works. Largely, from our side, we think it's not really, from working with, a lot of our customers, not really a concern, but, give it a try, see what happens. Next is design. And so what we have seen, with the transmit power limitations of 6 gigahertz, especially the asymmetry between AP and client, it is most advantageous to have a capacity-based design where clients can have strong signal wherever they are. They don't have to be on the fringe of the cell, and where the client TX power limitation would be seen the most. And then lastly is, think about your network. What do you have from a switching perspective for PoE, for mGig? Most of the Wi-Fi 7 and 6E APs, many of them need BT power for full functionality. Most of them have a AT operating mode for reduced functionality. We have many customers who use the AT operating mode, no concerns there. But think about the future if BT is appropriate, as well as mGig. Also not a requirement, but a nice to have. Now with 3 data radios, wider channels, there are, you can conceivably, and MLO I should say, you can conceivably achieve more than a gigabit per second in real world conditions on APs. So this is the, step 1, step 2, step 3 of, how do you actually get to Wi-Fi 7? How do you actually get to 6 gigahertz? And so let's say you've completed this. What happens to your network? Are there actually tangible benefits to 6 gigahertz? My answer is yes. And so it turns out we actually have a very good benchmark year over year. So the same event, a one-day event held year over year. So 2023, 2024, 2025. In 2023, the first year that we did it, the 6 gigahertz adoption was in the 10% range. And the graph here is the traffic by band. So the 6 gigahertz traffic was very low. I think even less than 10% of the total traffic. In 2024, the total amount of data transferred, increased from 3.8 terabytes to 6.8 terabytes, and the 6 gig adoption was in the 20 to 25% range, and then overall traffic volume was about a third on 6 gig. This year, traffic increased again to 11 terabytes, right? More 6 gigahertz, more capacity, right? Traffic increases. But most importantly, the 6 gig traffic volume is probably 40-45%, and then 5 gig is 55%. So the 6 gig contribution to the network is increasing. Maybe next year it will exceed it. And this is a European event where there's 480 megahertz spectrum. I think results would actually look different in the U.S. But it kind of brings up the point of the way that we think about 6 gigahertz, at least in Europe, is it's really an extension of 5 gig. You've doubled your available channels, and you can see traffic profile matches. So this is when I pulled this data, it was very encouraging to see.
Wes, for this event, were you seeing airtime contention originally, or
Yes.
So you've also alleviated the airtime contention by using 6 gig as well,
Correct.
right?
Yeah, that's one of the major benefits. Yes, absolutely.
Wes, it's great to see the overall RF traffic stats. Is there any granularity as to what is constituting the swing in traffic, like on a per application basis? Or
There's well, okay, not on. It's an event, so it's mostly email, people posting pictures and
all right,
and whatever. But there's more headroom for those people to do that stuff, which is why we're seeing the increase in traffic year over year.
be interesting to see how much of it could be related to AI. Naturally,
I don't know. And in the last 2 years, the 6 gig traffic volume increased 12 times.
Do you have similar data for an event that would be held like in the US or Canada where we could potentially have a lot more traffic?
Not to this, this is it's a repeatable, it's the same thing every year.
You can compare.
Yeah, so it makes it very easy to compare. We do have US data, but not to the same,
Okay. And they were using 20 megahertz wide channels on both bands?
First 2 years were 40s, and then this year was 20s.
Okay.
Sorry, 40s on 6, 20s on 5.
Okay.
And then this year is 20s on both bands.
Both bands. Okay.
Here's another example. This is a large university customer who is actually deploying about 1,000 APs a month in session. It's just incredible. But they have 60, 70,000 clients on the network. Around the end of the semester last year, after Thanksgiving, they decided to enable WPA3. Right? So they got their feet wet with WPA3. And then a few weeks later, at the end of the semester, over winter break, they actually turned on 6 gig. So when the students came back after winter break, this graph is the capacity SLE. And so before 6 gig, they're in the low to mid 90% capacity, which is pretty good for their size. But by turning on 6 gig right away, 25% of clients connected, and their capacity SLE improved about 5 percentage points. And at their scale, that's a significant improvement. So there's tangible benefits to 6 gig. I'm a huge proponent of it. The roaming piece I think is sorted. Security largely has been okay with especially WPA3 enterprise. And so yeah, I want that next year. I want that 50% number to be 70%, and then keep going up. I would be remiss if I didn't talk about 2x2 and 4x4 APs, because this is what the industry has settled on, and often the question comes up of why do you even have a 4x4 AP when you have 2x2? Is 2x2 all I need? And so just as a refresher, this is 2x2, 2 transmit chains on the AP, 2 receive chains, and so when you look at the antenna polar plots, often you'll see a line for each element, each transceiver, and then you'll see an outer line that's the composite. That composite line is usually would be with MIMO gain, and depending on the vendor, usually this is as measured. Hopefully it's as measured. Some people simulate, but these are from missed APs. They're as measured. And then 4x4, you have 4 lines, 1 for each radio chain, and then the composite line as well. So the theory is you have higher more MIMO gain in 4x4 and better receive for MRC. This is a MacBook client listening to the AP, and so just by changing the AP from 4x4 to 2x2 in software, right? Same AP, same client location, just by changing config from 4x4 to 2x2, the signal, as heard by the client, changed from neg 52 and it dropped to neg 57. So the math would be, usually you would expect about a 3 dB change going from 4x4 to 2x2. In this case, it was 5. We live in an imperfect world. It is what it is. But this is just listening to beacons, right? And our AP is actually beacon across all chains, which is why we see a difference here. But this is the initial piece of it. Okay, signal. We have a signal difference from. We can have a more robust signal with 4x4. How does that actually impact your data rates? So if we looked across the MIST universe. We pulled data rate versus signal strength on x-axis, and just looking at the trend, right? The trend goes up and to the right, which means the data rates went up and signal strength also went up for a 4x4 AP. Same thing on receive side, where the trend is also up and to the right. So there's the biggest difference, multiple dB difference in transmit, and then slightly smaller, 1 or 2 dB difference in receive. But that has actually a noticeable impact on the data rates. Again, more robust link between AP and client. So how does that actually relate to retries? Well, it lowers the retries, which is good. And then how does that actually relate to throughput? Throughput goes up. So I'm not getting super into the weeds here. It's just meant to be a high level of there is actually a benefit. You have a more robust RF link, and that does lead to speed improvements. User experience performance on the network with 4x4 APs. Now, does that mean 2x2 is useless? No, right? It's all relative. Like it's what you need on the network, and certainly for the most demanding of environments, we would recommend 4x4.
With this data, would there be diminishing returns if you had a, say, 8x8 or a 16x16 that is technically feasible in the standard?
Yeah, you would see improvements, but it gets to, where does it start and stop mattering? I think with 4x4, we're kind of at that sweet spot of power, price, and performance. Okay, next up is the use of directional antennas for everyday use. And so this is something we've been exploring. We released the AP47D. This is a AP47D with directional antennas, built-in directional antennas to the AP. And so the reasons, for this AP are several. And so we've seen a increasing desire from our customers to have higher AP density in everyday environments. This is your offices, maybe auditoriums, and our retail customers as well, where they need higher AP density. But if you're deploying Omni APs, even with, our APs have 30-degree down tilt, even with the down tilt, at some point you get to a point where you have too many APs. Your roaming sucks, co-channel problems. You really have to tune at that point when you've deployed too many APs for your environment. And so the solution to that is, okay, let's go deploy some directional antennas. And typically we're doing that with AP45E, which works, very well. But feedback from customers is it's kind of a pain. We got to plug in the AP, the connectors to the AP, got to mount it. It's harder to make it look nice. It's more costly to install, and got to pay for the antennas. And so, we've actually had like a bunch of enterprise customers, corporate enterprise, deploy 45Es in their office environments, right? Because they have such density, such utilization in the office, that they need the directionality. That's why there's a 47D for those types of environments. We think it's going to be useful in those corporate enterprise, in auditoriums. It's going to be useful in even some of our retail customers, to help support 6 gig density in those environments. This AP is specifically a 60x60 square pattern. And so that gives the advantage of it. It reduces co-channel contention. It reduces, the AP can't hear as well. So it doesn't. There's other crap out there. It doesn't care as much about it. And clients also don't hear as many APs, right, which also turns out to be a big problem in these really dense environments.
Wes, Any plans in having like a 40 by 40 or 30 by 30? Is that even doable, like with the physics?
No comment. This isn't a one size fits all. There's still absolutely a use for external antennas. We released a AP47E with external antennas. Especially in the more challenging environments like warehouse, particularly, we use a long narrow pattern style antenna, or high density where we don't have the 30 by 30 today, and other niche environments. So as far as some testing, here is a auditorium. This is a lecture hall at a university. It already had 45E antennas, 45E APs with directional antennas. In this particular beam, there's 3 APs. We just took down the AP45 in the middle, put up the 47D. So from a results perspective, and you can't really make it out on the projector, but on the stream, you should be able to see the color difference. So in the middle, those 2 APs in the middle are the 47D, 5 gig and 6 gig. And then on the left and right on the top row are the existing 45Es. And so the coverage pattern between the 45E, which is using on paper like a 45 by 45 antenna, I think, is the pattern is actually very similar, which is encouraging to see. This particular customer was very happy. They're going to actually go forward. All their auditoriums going forward will be 47D. It gives them the added benefit of they can support low power indoor on the AP. They don't have to worry about standard power. And then for comparison, the 2 bottom APs are Omni 45s that just permeate everywhere in the room. So there's absolutely benefits to the directionality for this particular environment. So I just wanted to show some real values, real testing.
Why the 2x2 for the 47D when it's expected to be used in higher density spaces?
They didn't have full power. We didn't fully power it.
Okay.
So for this testing, we didn't really care about it. But yeah, just to note
so the product is 4x4.
Correct.
Okay, it
Yes.
just wasn't in this test.
Correct. And so you can account for that. Just the signal strength doesn't match up exactly with the 45E. Mostly we actually see about a 3 dB difference, which is what you expect going from 2x2 to 4x4. Okay, and then next piece is dual 5 gigahertz and dual 6 gigahertz. AP47 is capable of dual 6 gigahertz as well as dual 5. On our previous APs, we've supported dual 5 as well. And I want to get into a little bit of the nuance that we've learned with dual 5 over the years. So first is, most vendors out there, and this is how we, do our dual 5, have settled on this sign of, this kind of architecture where you have one radio that uses the lower portion of the spectrum, one radio that uses the higher portion of the spectrum, and you put a bandpass filter in the middle, so you can achieve incredible interference rejection with the co-located radios. Same thing on 6 gig. We're using Uni 5 low band, Uni 6, Uni 7, and Uni 8 as high, and then Uni 6 as a guard band, which means for Europe and UK and other countries with 500 megahertz spectrum, dual 6 not useful right now for you. However, actually today, 40 minutes ago, the UK had consultation for opening up the entire 6 gig band for for indoor use. Now this is consultation; they're taking feedback. It just closed, but that would be actually very encouraging for opening up the additional spectrum, and they also want to turn on AFC for outdoor use cases. That would probably be longer term. But if you read actually phase 1, ideally by the end of 2025. So that's very fast in spectrum timelines, regulatory timelines. So we'll see what actually comes back in the consultation. But this is what they want to do at least, and would help with the dual 6 in UK.
And it said EU is still in planning. Do you know what they're?
Yeah. So EU had a I forget what they call it, MRD, or they had their radio group consultation 2 years ago. The next one is in 2028 or something.
Oh, good Lord.
And so they said, we want to do it, but we'll decide by the next one.
Thank you.
Yep. So then what does that actually mean in terms of channelization? Well, on dual 5, you have 8 channels on lower, and depending on 16, 17 on higher. AP47 we support Uni 4, so there's actually 20 channels on the upper. That channel mismatch, right, turns out to be a problem. It means that you can't just turn on dual 5 everywhere, because then you've reduced the number of available channels that you have. Right? You run into channel reuse issues. Especially if you do 40 megahertz, you have 4 APs before reuse issues. On 6 gig, not so much of an issue, because it's more equitable. There's a better balance. Now, to just really drive home the 40 megahertz point, you can see in here there's a lot of reuse. So this is like an example of what not to do, but it kind of drives my next conversation, which is, let's think about what are we actually trying to do. We're trying to increase the capacity on the network by having more available radios on 5 gig or 6 gig. So it turns out not all capacity issues are the same. Kind of comes down to, hey, maybe I need to add some more APs. Like my clients are using, there's no other capacity, there's no headroom, I need to add more APs. Or, conversely, it could be I have too many APs. I'm interfering with myself, or a neighbor's interfering with me. And so that leads us to, how do we actually, let's actually bake that into RRM from, we've had this auto conversion feature for many years. It's worked incredibly well. We use it all over the place, where we can convert automatically the 2.4 radio into 5 gig, into 6 gig now on AP47. But what we have seen is, in many instances, the radios that we're converting aren't actually the highest utilized APs that could benefit the most from that additional radio in 5 gig or 6 gig. That's what we want to solve. So today we have a density-based approach where we're looking at the density of APs. Do I have enough density to support this auto conversion or auto cancellation? What we are moving to is a capacity-based approach. Sounds simple, but there's actually a lot that goes into it. And so we change our questioning from, do I have enough density, to, can I do it? Do I need it? Where do I need it? Right. So can I do it is are there enough channels enabled in my configuration? How many other APs do I hear? Are there available channels from a capacity standpoint for me to do it? Do I need it? Meaning, do I actually have the utilization characteristics to take advantage of additional 5 gig radio or additional 6 gig radio? And then where do I need it? Right? Where on the network do I need it? So I on a previous MFD, I've shown this slide, which is, we want to learn the behavior of the site. What is the 5 gig utilization, 6 gig utilization? What is the roaming? How much dwell time? All these things. And so this we are learning, we are doing, and that feeds into this new reimagination of the auto conversion part of RRM. So this plot on the left hand side is it's an environment. The blue APs are APs that we're happy with. There's no they're happy as they are, right? They have plenty of headroom. The red APs are APs that are the high utilized APs that are having capacity headroom issues. These are candidates for auto conversion. On the right hand side is actually what the algorithm did. Right? So the first step is we have to identify these high use APs. Second step is let's actually go convert. So, many environments, especially in retail, you may not have all the available channels. They may turn off some of the DFS channels. So this is with 15 available channels in their in this configuration. The black APs turned out to be the APs that we actually converted. And so this is, okay, so what does that actually mean? Well, here's the outcome. Looking at one of these APs, the blue line's before, and then the red and the green is after on both radios. So blue before, if the left-hand side is the number of clients versus the number of samples. So there's, mostly 15 to 25 clients on the AP. After the number, we had actually good distribution between the radios in terms of number of clients. That decreased. Utilization is on the graph on the right. Utilization decreased significantly after.
Was it going to dual 5 or dual 6?
Dual 5. This is dual 5. This is a AP43 customer.
Okay.
And then the actual throughput in the AP went up as well. So that's the entire goal of this exercise is how do we identify the APs where we have headroom issues? And then let's go figure out if we can alleviate that.
And going forward, how are you going to make a decision between whether you go to a dual 5 or dual 6?
Yep.
So if you go, yes, we need more capacity, are you going to look at like how many clients are on each band or?
This is why we have to learn the behavior of the site. We can make those decisions. We can make a bandwidth decision as well. Like, do we change the bandwidth? Do we change the band? Do we go 5? Do we go 6? Do we mix it? Yes, that's why we need this. This is the foundation of understanding the behavior in the site. Then we can do all this other stuff.
And so this is going to be sort of a learning thing that occurs after your Mist network is up for 6 weeks. You then have the option of doing the thing because we've learned enough about your network, or is this going to be a model that applies to all networks?
This will be a learning based on your network.
Okay.
And so when you deploy, we will do some stuff right away, and then over time it'll get better. So it's not like you're sitting there waiting, but over time we will. Even today if you stand up Mist APs, the second day, third day, the RRM even gets better because we have that reinforcement learning loop.
Okay. And so this would be part of that.
Yes.
Okay.
Absolutely.
I had a question. If you make those changes to the black ones, how do you know whether it was a good change?
Part of the reinforcement loop. So we looked. So today we're already consuming our capacity SLE and coverage SLE and roaming SLEs. So we make a change. I should have put the slide in. I was thinking about it. So we make the change. We monitor. These are representation of client experience. So if capacity goes down, that's a bad change. Right? If capacity goes up, if we're actually trying to improve our headroom. Right? So if the headroom goes up, then that's a good change. We stay. Today we don't. Like in today's algorithm, we only go one way. We will go 2 ways in the new world.
Is there something planned to get rid of the other red ones?
The problem is, in this particular case, they also how do we get to dual 5? How do we get to dual 6? We convert a 2.4 radio. They have 2.4 utilization, so we have to be cognizant that there's 2.4 utilization and not cause coverage gaps. And the other problem is, in this particular environment, they only have 15 available channels. So if I convert more radios to dual 5, I'm not actually picking up any capacity gains.
But could it also recommend you should go to 6 gig? And in this scenario, you need different hardware.
Correct. Yeah, that is absolutely part of, we have to recognize when we've done all we can and there's simply no more capacity.
Will customers be able to blend both a density approach and a capacity approach to, the optimization of the site?
Yeah, so the capacity approach consumes the density approach, where we are still considering the density of APs to make sure there's sufficient density, to support any 2.4 utilization.
All right.
So the reinforcement learning algorithm, you mentioned it takes into account capacity, roaming, and what was the other SLE? You mentioned 3.
Coverage.
Coverage. Because has that changed recently? Because did it used to just be capacity?
It used to be capacity coverage, and 2 or 3 years ago we introduced the roaming SLE for the purpose of feeding into RRM.